Hi, coming to the next part of this stress analysis, we came across what is stress and the components of stress. Next is the important things what we have to consider in stress. I'm Reshma Raj from Civil Engineering Department of SNS Institutions, Coimbatore. So we talked about the previous video about the stress, what is stress and what is the components of stress and how much compression, what in what members compression, in what members tension, and the assumptions made. Based on the assumptions, some analysis we have to take care very importantly in stress, and for simplifying some assumptions we have to take care of the analysis portion. So as you all know that the truss itself having a centroidal axis, so each member centroidal axis coincides with the line connecting the centers of the adjacent members, and the members only carry the axial force. So this is the primary and very important assumptions that can simplify the stress analysis. So we all know that each member is holding some centroidal axis. That centroidal axis should coincide with the member of the line connecting the adjacent members, and that member will carry the axial forces. And the next very important assumption is all members are connected only at their ends by mainly frictionless hinges in plain trusses. That is the very important another assumptions. Why we are using these assumptions is to simplify the analysis of truss actually. And all loads and support reactions are applied only at the joints. So whatever the loads and the support reactions, every reactions are being reacted only at the joints, not in the intermediate of any kind of members. So next is method of joints. The axial forces in the members. So mostly because of the centroidal axis, axial forces will be acting, and the axial forces in the members of a statically determinate truss are determined by considering some equilibrium of its joints. So what are the equilibrium we can consider as tensile axial member force, one equilibrium. So tensile axial member force. What is tensile axial member force? It is indicated on the joint by an arrow pulling away from the joint. And what is compression? As you all know that it is indicate bringing an arrow that pushing towards the joint. So pushing towards the joint is known as compression, and away from the joint it is known as tension. So these are the other important assumptions. And next is important for analysis, we have to consider zero force members. So what is zero force member? If any two non-collinear members are connected to a joint that has no external loads or reaction applied to it, then the force in both members must be zero. That is known as zero members. It doesn't mean that it doesn't have carrying any kind of load. It is carrying the load, but it is called it doesn't having any external and external force acting on it, which is or external loads acting on it, which is known as zero force members. So if three members, we talked about two collinear members. If three members, two of which are collinear, are connected to a joint that has no external loads or reaction applied to it, then the force in the member that is not collinear is zero. This is the case where three members are acting and in which the two members are collinear and connected to a joint that has no external loads or reactions. So that member or that force of the member is considered as zero. Hope you understand. Next is method of sections. It enables to determine forces in specific members directly. So method of sections, what we can able to talk is, it involves cutting the truss in two portions, like you see in the free body diagram, by passing an imaginary section through members whose forces are desired. So desired member forces are determined by considering equilibrium of one of the two free body diagram of the truss. So this is another as an important method to find the forces acting on each member of the truss. So as you see, this is one kind of failure in truss will occur, which is known as buckling, and this occurs due to shear forces. And you can see in the two diagrams, one is truss before lateral buckling and lateral buckling of truss. So lateral buckling is something like which can be uh, a hiccups can be occurred in the shape of the truss is known as lateral buckling. So likewise it can able to fails the structure. Next is method to prevent buckling. So planar truss with stiffened top coats to provide resistance. So we have to stiffen the top coats that can resist the lateral buckling. In three-dimensional truss, width of the plane provides resistance to lateral buckling. So we have to increase the width of the truss. And in three-dimensional truss, slope side members provide resistance to. So the slope, why we are making the slope in the both sides of the trusses is for avoiding the lateral buckling. So that's all about the stress analysis, the assumptions, and non-collinear non-collinear sections, and what is zero member sections, and what is like buckling, lateral buckling, how we can avoid this buckling. Everything we have covered in this. So further more about the stress analysis we will be watching in part 3. Let's go. Thank you.